My name is Tyler Labonte, and on behalf of my co-authors Vidya Muthukumar and Abhishek Kumar, I will be presenting our NeurIPS 2023 paper towards last layer retraining for group robustness with fewer annotations. Deep neural networks are susceptible to spurious correlations, patterns which are predictive of the target label in the training dataset, but are irrelevant to the true labeling function. These spurious correlations cause the model to have poor performance on data where the correlation does not hold. To formalize this phenomenon, we divide the dataset into groups, formed by the Cartesian product of the class labels and the spurious feature. Our objective is to maximize the worst group accuracy. This is particularly important for ensuring good performance on minority groups, which may be underrepresented in the training dataset. Group robustness methods often use group annotations for training. However, these group annotations may be impractical to obtain due to financial, privacy, or fairness concerns. Deep feature reweighting is a state-of-the-art technique for group robustness. In this method, ERM is first trained as usual, then a group-balanced held-out dataset is used to retrain only the last layer. This technique does not require group annotations in the training dataset like group DRO, but it still does require group annotations in the held-out dataset. In our work, we investigate the performance of last layer retraining without any group annotations at all, and we come up with 3 key insights. First, we show that the effect of last layer retraining is largely due to class balancing, and perfect group balance is not necessary to improve over ERM. Second, we show that retraining on a held-out subset of the training dataset can greatly improve worst group accuracy. This is surprising because the training dataset and the held-out dataset are equally group imbalanced. Finally, we propose the selective last layer fine-tuning algorithm, which uses model disagreements to match DFR without group annotations. We perform an ablation on the percent of worst group data used for last layer retraining. Here, ERM is not class balanced, but the held-out dataset is class balanced. While performance tends to increase with more worst group data, the large improvements at low percentages indicate that class balancing can be a major factor in performance. Here is the same plot, but the y-axis is now relative to percent increase in worst group accuracy over ERM. In this plot, we can see that an average of 2/3 of the group balance benefit comes from the first 1/3 of worst group data. In particular, this raises the question of what would happen if we just retrained the last layer on a held-out subset of the training dataset. In fact, this technique surprisingly improves even over class-balanced ERM. The blue bar here is ERM trained with 100% of the data, while the orange bar is trained with 95% of the data, and then last layer retraining is performed with the remaining 5%. Therefore, we propose that last layer retraining is a free lunch in group robustness. This simple method improves worst group accuracy with no extra data or annotations needed beyond ERM, even for model selection. This free lunch brings impressive performance benefits, but still trails annotation level robustness on Celeb and multi-NLI. Therefore, we propose to use the model's latent knowledge to upsample worst group data in the held-out set. This can be achieved by computing the misclassifications, as has been studied in the literature, or as we propose, computing the disagreements between the ERM model and a regularized model. We compare using different types of misclassification and disagreement for our self algorithm, and we find that early stop disagreement self performs consistently well and nearly matches DFR. We propose 2 hypotheses for this good performance. First, disagreement methods work regardless of the worst group accuracy trend over training. While early stop misclassification assumes that the worst group accuracy starts low and increases over training, this is not the case on datasets such as civil comments. On the other hand, disagreement performs well as long as the worst group accuracy changes significantly over training. Second, we hypothesize that misclassifications are difficult while disagreements are uncertain. In particular, the held-out training accuracy of the misclassification methods is very low, evidence that misclassifications are too difficult to learn without modifying the features.